Hello, Breakout Honor students. Mrs. Myers here. We are still working in Chapter 7. We got one more day left of Section 3. Okay, we're finishing this up today. So this lesson follows directly from the previous lesson in that we are still doing partial fraction decomposition. Okay, but we're going to do a couple other things with respect to partial fraction decomposition, okay? And we're going to touch on what we talked about from the previous lesson. So if you had any kind of difficulties, hopefully we'll be able to get some things cleared up with this lesson, okay? So the first thing that we're going to take a look at is an example where the numerator is a larger degree than the denominator, okay? Or the same. If it was the same or larger, okay, I just happen to pick one that's larger. Okay, the first thing that you need to do before you can find out the fractions you're going to add together to get the original fraction is you need to do long division, because as we saw back way back in the beginning of the year when we were doing a rational function graphing, okay, is that whenever the numerator's degree is the same or higher than the denominator's degree, it's going to divide in a whole number of times, okay? So we're going to do that here, okay? We're going to take x squared plus 3x plus 2. We're going to divide that into 2x cubed minus x squared plus x plus 5. So a couple things to just caution you against when you're doing your division, okay? So this has to be long division because the divisor, what you're dividing by, is degree 2, and you can't use synthetic division unless you have degree 1. So for anyone who's thinking that, you definitely got to do long division here. The other thing is make sure that your dividend and your divisor don't have any missing terms. Now we don't have any missing terms here because we go from degree 3 to degree 2 to degree 1 to degree 0, which is our constant and our dividend. And then we have our degree 2, degree 1, degree 0 in our divisor. So we're ready to go. So how we begin, right, is we take the first term of our divisor, the first term of our dividend, and we see how that divides in. So in other words, what does x squared need to be multiplied by in order to get the 2x cubed? And that would have to be 2x. So we're going to put that right there over the like term. So we multiply that 2x by every term of the divisor, and we get the 2x cubed plus 6x squared plus 4x. Notice how I'm lining it up with the like terms. And then we're going to subtract that quantity as a whole. Okay, so we got 2x cubed minus 2x cubed, that's nothing. We got negative x squared minus 6x squared, that gives me negative 7x squared. And then positive x minus 4x, that gives me negative 3x. And I bring down that plus 5, okay? So next is I'm going to take this x squared and divide it into negative 7x squared. So that's going to be a negative 7. Okay, again, distribute that through the divisor. So it's negative 7x squared minus 21x and minus 14. Okay, I'm going to subtract out that quantity. And negative 7x squared minus negative 7x squared, no more x squareds. Negative 3x minus negative 21x really means negative 3x plus 21x, and that's 18x. And then 5 minus negative 14, in other words, 5 plus 14, and that is 19, okay? So that's our remainder, and that gets put over our quotient, right? Put over our divisor to make for our quotient. So really, what we just did right here is we said that this is equal to 2x minus 7 plus 18x plus 19 all over x squared plus 3x plus 2. So this is really a denominator of 1. So that's one fraction that needs to add to this fraction in order to get this original fraction. But this needs to be decomposed some more. So here's where we're going to pick up, okay? So the first thing we want to do is factor this denominator. This factors very nicely into just x plus 2, x plus 1, okay? And that is going to be broken up into two fractions, right? So we are going to take this. Okay, one fraction is going to have a denominator of x plus 2. Oops, I don't know why I put that extra mark. The other fraction is going to have a denominator of x plus 1. Okay, these are just both what we call linear factors. There's no repeated factor or anything. All right, so our numerator here is just some constant. We'll call it a. The numerator here is just some constant. We'll call that b. And now we're going to get the common denominator across the board here. So it'll be 18x plus 19 all over the x plus 2, x plus 1 denominator. Okay, and that's going to equal, right, what numerator over this common denominator of x plus 2, x plus 1, and that would have to be a times x plus 1. And then over here, get this denominator to also be x plus 2, x plus 1. So what would this numerator be? This numerator would be b times x plus 2. So now that means that if I was to multiply this whole entire fractional equation through by this LCD here that I've got across the board, I would basically just have this numerator of 18x plus 19 equaling this numerator of, what did I just distribute here, ax plus a, plus this numerator here, which is bx plus 2b. And then hopefully this looks like exactly where you did with the previous lesson, and we just go ahead and we regroup and set like parts equal to each other. So we have x times the quantity of a plus b, and then plus a plus 2b. So that must mean that this 18 was equal to a plus b. That must mean that that 19, that constant, was equal to a plus 2b. And then I just solved that 2 by 2 system very easily. I'm going to suggest we multiply the top through by a -1 and get negative 18 is equal to negative a minus b. Keep the denominator exactly the same. Sorry, that second fraction, second equation. Okay, keep the 19 equals a plus 2b the same. Add these together and we get 1 is equal to b, and then we're good to go. So now we get to our a value. Well, if I know that a plus b is equal to 18, then I must know that a is equal to 17. So then I just go back to my original problem, and I've got myself my 2x cubed minus x squared plus x plus 5 all over x squared plus 3x plus 2, and that would have to equal 2x minus 7 plus my a value of 17 goes over the x plus 2, and then that b value of 1 goes over the x plus 1, and I'm all set. All right, so let's just do another couple more problems here. All right, so next example, okay, is I'm going to go back to our numerator's degree being less than our denominator's degree. Okay, so we do not need to worry about the long division there or anything. Okay, we are going to start off, of course, by completely factoring that denominator. Notice how there's 4 terms, though, here. So this can only be factored by grouping. So I'm going to factor out the x squared here. That's in common. And, of course, I'll just factor out a 1 there to make that be exactly x minus 1, so I can keep going with my factoring by grouping. So when I take out x minus 1 here, I'm left with x squared plus 1. Okay, so I've got my factoring done. Okay, can't factor x squared plus 1 any further. If it was x squared minus 1, I could, but not x squared plus 1. So I've got myself 2 fractions that this is going to decompose into, x minus 1 and x squared plus 1. Okay, so now the new thing here with this problem is that this denominator here is not a linear factor. Okay, this is not a degree 1 factor. This is a degree 1 factor because it's just plain old x raised to the first power. So this numerator at best was a constant, so I'll just call that a. Now, because this denominator is degree 2, then this numerator was potentially degree 1. So I've got to call this bx plus c. Okay, so because it's degree 2, there's always going to be, at most 1 less as the degree. Okay, or else there's no way I would have gotten to, a fraction where the numerator's degree was less than the denominator's degree. Okay, so I have to account for the possibility of this numerator having a degree 1 term in it, as well as a degree 0 term, a constant. Now, I might not have had both terms in that numerator. I might have only the degree 1 and not the degree 0, or only the degree 0 and not the degree 1. And if that's the case, then I would get b or c to be a 0. So let's just see what happens, okay? So now that this is my fraction x squared plus 2x over x minus 1 times x squared plus 1, okay, I want to get these denominators to be exactly the same. And I just got to see how I have to adjust those numerators, okay? So this numerator here, a, has to be multiplied by x squared plus 1. And this numerator here, bx plus c, has to be multiplied by x minus 1. And now I am going to, again, think about multiplying through by this LCD, and I would have just x squared plus 2x equaling the sum of those numerators. Now while I'm at it right now, why don't I just distribute here and get ax squared plus a, and over here I'm going to get bx squared minus bx plus cx minus c, right? Make sure you fully distribute there. Here, that's just the distribution. So let's group together these like terms. So I can take out the x squared and I would have just a plus b. Right, these two terms, I can take out the x and I would have c minus b. Of course, you can call that negative b plus c. All right, and then I have these two constants here, which would be the a and this minus c. So one like term at a time, 1x squared, x squared times a plus b. So I know 1 has to equal a plus b. And then here I've got 2x, and then here x times c minus b. So 2 has got to equal c minus b. And then here I've got a minus c as a constant, and I don't have anything there, so I'm going to say 0 has to equal a minus c. All right, so this is a 3x3 system, so just take a good look at, what you want to do here. So I've got, this has a and b, this has b and c, and this is a and c. Well, for example, if I take these two equations right here, and I add them together, okay, well, what's going to happen is I'm going to get these c's to just cancel right out, right? They're going to zero each other right out, and I'm going to have 2 is equal to a minus b. Well, if I put that together with 1 is equal to a plus b, well, now I've got myself a 2x2 system, and I can easily just add these together and get 3 is equal to 2a, no more b's, and a is equal to 3/2. All right, and then I could just keep going. So if a plus b is equal to 1, so 3/2 plus b has to equal 1. All right, so minus the 3/2 from b both sides, and b has to equal negative 1/2. And then last but not least, okay, so a minus c has to equal 0. So if a is 3/2, and c is also 3/2, right? So they would have to be the same. That would also have to say a is equal to c. So now I would just have my original problem being x squared plus 2x over x cubed minus x squared plus x minus 1, and that's equal to my a value of 3/2 over x minus 1, and my b value of negative 1/2, and my c value of 3/2 all over the x squared plus 1. All right, and it's okay to leave that those fractions in the numerator, or you could take that denominator of 2 in the numerator and bring it in there. So that would be another way of saying this would be 3 over 2 times the quantity of x minus plus 1. And then here I would have negative x plus 3 all over 2 times the quantity of x squared plus 1. That's fine. And of course you can call that 3 minus x. You could also factor out the negative and make this be a subtraction, and then this would be x minus 3. So there's lots of different ways that you could give that answer. Okay? All right, so we're going to do one more together, okay? So one more problem, and that's going to be 3x cubed plus 4x over x to the 4th plus 2x squared plus 1. Okay, so we don't have our numerator degree being the same or larger than our denominator's degree, so we don't have to do that long division thing that we did in the first problem. Okay, we're going to fully factor our denominator, and this is a trinomial. So if this is going to factor, it's going to factor in 2 binomials. And since I have positive 1 at the end, it's got to be a 1 times 1. So how can I have these first two terms multiply to be x to the 4th, and then have these other two products become 2x squareds if they were each x squared? Right? See, x squared times x squared is x to the 4th, and then 1x squared combined with another 1x squared, that gives me the 2x squared. Now the thing about this is x squared plus 1 quantity squared, because they're exactly the same factor, right? So this brings us back into the whole repeated factor thing, okay? So I have x squared plus 1 quantity squared as a denominator, for sure. I mean, I have to have that as a denominator, or else how would it be this matching up this one? But I might have also had a fraction that was just plain old x squared plus 1 to the power of 1. Okay, so whenever you have your repeated factor, you've got to account for all the lesser number of times that you could have had that. So for example, if this is x squared plus 1 quantity cubed, then I would need x squared plus 1 quantity squared and x squared plus 1. Okay, if this was x squared plus 1 to the 4th power, Then I would also need a fraction for x squared plus 1 to the third power, x squared plus 1 to the second power, and x squared plus 1, okay? You always got to account for all the different possibilities of how many times you could have had them, because no matter what, this would still be the LCD of all of them, okay? Now, the thing is, each of these factors, it's the exact same x squared plus 1 factor, is not a linear factor. They're not degree 1 factors, they're degree 2 factors. See, the power of 2 there, just like we had over here. So each of these numerators might have a degree 1 and degree 0 term in them. So here I'm going to call this numerator ax plus b, and I'm going to call this numerator cx plus d. Okay, I got to call them different variables, okay? So I've got my 3x cubed plus 4x over x squared plus 1 quantity squared fraction. Now this denominator is x squared plus 1 quantity squared, so I don't have to change this numerator at all. But this numerator, if the denominator is going to become x squared plus 1 quantity squared, then this cx plus d has to be multiplied by x squared plus 1. All right, so let's see what happens here, okay? Looks like it's going to be pretty crazy, but it's really not going to be that bad at all, okay? So we've got 3x cubed plus 4x all over, I don't want to put that all over. I'm going to just do 3x squared cubed plus 4x, and I want to say it's equal to this numerator of ax plus b plus this numerator of, now this would be cx cubed, and let's go in order here, of then dx squared, and then plus cx, and then plus d, okay? Now here I have only that one cubic term. I have only that one quadratic term there, okay, degree 3, degree 2. I do have these two degree 1 terms, so I factor out the x, and I'm left with a plus c. And then I have these two constants here of the b and the d, okay? And that's going to equal 3x cubed, okay? No x squareds, right? 4x and plus 0. So that means that this c has to be 3. There's no other choice because it's cubic. That means that d has to be 0, okay? Because I've got no other squared term at all. So d's got to be 0. Now I've got this a plus c has got to be 4, right? Because that's the x and that's the x. And then I've got this b plus d quantity has got to be equal to a 0. So what that means, if c is 3, that means a has got to be 1. And if b plus d has to be 0 and d is 0, well then b also has to be equal to 0. All right, so now I'm just ready to write my final answer, and I've kind of run out of room here a little bit, so pardon me, but I've got ax plus b. So again, a is 1, b is 0, so that's just x over x squared plus 1 quantity squared, okay? And I've got over here with my other fraction, cx plus d, well, the c is 3 and the d is 0, so that's just 3x, pardon my dogs, over, and then it's just x squared plus 1. Sorry, it's hard to write on the bottom of the paper and hold the phone to record at the same time. And then that's it, okay? And then this would be the partial fraction decomposition to that original problem. Okay, so hopefully you understood these problems, and it's going to be able to help you out to do the few homework problems that you have for tonight. All right, hope everyone is well. If you have any questions on this and you'd like to join me for Wednesday's Google Meet, that would be great. And if I don't talk to you then, just hopefully another time. Hope everyone's well.